Okay, so how do we solve a linear system by graphing? One method is to graph the equations carefully on the same coordinate grid and find their point of intersection. This point is called the solution of the system. All right, so you want to do this with paper and pencil and try to get a straight edge, like use a sheet of another piece of paper or a ruler so you can draw the line accurately. You want to try to also use graph paper when you can. If you just uh, draw your own coordinate plane, it's going to be very hard to see where the 2 points intersect accurately, or the 2 lines intersect. You might get it where they cross, but the point where they cross you might not be as accurate. So anyway, let's graph the first one. Y equals negative 3x plus 10. Remember, it's in the form y equals mx plus b, where m is the slope and b is the y-intercept. So you graph the y-intercept first, it's 10. And then from there you follow the slope, which would be down 3 over 1. Down 3 over 1. Okay, and then I'm going to try to put a line on there. Okay, that's our first one. And the second one is x minus 2. So the y-intercept is negative 2, and the slope is 1. So you would just go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Keep going like that. So your line would look like this. All right. And so we could put our arrows on the lines, and you can see that they intersect right there, and the solution is 3, 1. So you can check that by substituting that point into each equation. So if you can look under my writing here, if I do it in the first one, I put 3 in for x and 1 in for y, and simplify, I get 1 equals 1. Do it for the second equation because it should be a solution to both. Put 3 in for x and 1 in for y, and they both work. Okay? All right, this second one, now you could solve this for y, or you could use intercepts to graph it. So if I want to use intercepts, to get the y-intercept, you plug in 0 for x and solve for y. If I plug in 0 for x, it'd be 2 times 0 minus y equals negative 1, which is negative y equals negative 1. So y would equal 1. So the y-intercept is 1. And then the x-intercept, you plug 0 in for y and solve for x. So you would end up with 2x equals negative 1. So x would equal negative 1/2, which would be right about there. So again, it's going to be kind of difficult to draw this accurately using my iPad, but do the best we can. So for this one, 4x minus 2y equals 6. To get the y-intercept, plug in 0 for x, solve for y. You would get negative 2y equals 6, and y equals negative 2y equals 6, y equals negative 3. So down here. And then if I plug in 0 for y and solve for x, I get the x-intercept, so you'd end up with 4x equals 6, so x equals 6/4, which is 3/2, which is 1.5, which is over here. So get your line, draw it accurately right there. And now this is good that this happened, because you can see from my graphs that what I've graphed so far do not intersect. But what's interesting is if you keep extending these lines out, now I'm going to probably butcher this, they eventually do cross there. Now, just a minute. Now, I messed something up along the way there. Scratch that. Let's clear that one off. Now you can use intercepts, but I want to show you something here. If I solve this equation for y, negative y equals negative 2x minus 1, and then divide by negative 1, you get y equals 2x plus 1. If I solve this one for y, I would get negative 2y equals negative 4x plus 6, divide by negative 2, and you would get y equals 2x minus 3. You can see that these two equations have the same slope. So I messed up one of the one of the intercepts when I did it. So you could use intercepts, which is fine. And if you solve each equation for y to get it in slope-intercept form, remember y equals mx plus b. Okay. And you could see the slope. Since the slopes are exactly the same and you have different y-intercepts, that means that you're going to have two different lines. Now, if the y-intercepts were the same and the slopes were the same, then it would be the same line, and it would have infinitely many solutions. So this one, they're parallel lines that do not overlap, so there is no solution here. Okay? And therefore, this system would be called inconsistent. All right, here's one for you to try. Go ahead and pause the video and hit play when you're ready. All right, we're back. So 2a, x minus y equals 2. If I do the y-intercept, you would have negative y equals 2. So divide by negative 1, you have y equals 2. If I did the x-intercept, you would have plug in 0 for y, and x would equal 2. Okay, so if x is 2, y is negative 2, and then your line goes like that. And then the second equation, if I plug in 0 for x, you get 3y equals 9, so y equals 3. If I plug 0 in for y, I get 2x equals 9, so x equals 9 halves, which is 4.5. So y equals 3, x equals 4.5, right there, the line, going right there. And if you look, points about at 3, 1. And I'm going to tell you that that is the solution, and that will be called consistent and independent. It's consistent because there's at least one solution, independent because they're two separate lines. Okay, let's do B. Y equals negative 2x minus 3. That's the first equation. So I would go down 3, and then the slope's negative 2, so go down 2 over 1. Oops, down 2 over 1, and then put your line right there. And then the second equation, oops, you have 6x plus 3y equals negative 9. If I solve that for y, I would have 3y equals negative 6x minus 9. Divide by 3. You have y equals negative 2x minus 3. Same equation, so they would be lines right on top of each other, which means there'd be infinitely many solutions, and the system would be consistent and dependent. Okay? Alrighty. So the number of girls participating in high school soccer and track and field has steadily increased over the past few years. Use the information in the table to predict the approximate year when the number of girls participating in the two sports will be the same. So here they tell you the number of girls participating in 2008 and the average rate of increase thousands per year in track and field and soccer. So the number of girls equals the rate of increase times the number of years plus the number participating in 2008. So think of it like 2008 is your starting point. So that's for soccer, it'd be 345. And each year they add 8 more. So 8 times the number of years. So for soccer, it'd be y equals 8x plus 345. And for track and field, you have 458 is the initial amount in 3 people per year. So be y equals 3x plus 458. So those are our two equations, and we'd want to graph both of those. So you have to do some tricky scaling, like your x-axis should be scaled by 2s, and your y-axis you want to scale by 40s. And if you graph them, your point's all the way out here at 23. So the graph appears to intersect at about 22.5, 525. Now, I'm just showing you how to write equations and graph them from a verbal situation. With a graph this big and scaling that you have to go up by this many chunks, especially on the y-axis, it's going to be pretty difficult to estimate like the exact answer here. So if you had to do the same problem and you got like 20 or 23 or 25 or something because you had to guess because you couldn't tell exactly where the point is, that would be fine. For the most part, when they ask you to solve a systems of equations by graphing, it's going to be if you do the problem correctly, it's going to be very clear where the two graphs intersect. Okay, but if they intersect at some weird point, you either A, perhaps did something wrong, or B, you're going to have to use a different method for solving the systems of equations, which we'll go over in one of the future lessons. Okay? So we can check this solution using substitution in both equations. Plug in 22.5 for x and 525 for y in both equations, and you'll see that they pretty much work. See, even here, it's not exactly the exact right answer, but it would be after about 22.5 years. All right, so the solution means that approximately 22 years after 2008, or the year 2030, the number of girls participating in high school soccer and track and field will be about the same, and that will be about 525, but remember 525,000 because the numbers were in the thousands. All right, here's one for you to try. Joe and Josh each want to buy a video game. Joe has $14 and saves $10 a week. Josh has $26 and saves $7 a week. And how many weeks will they have the same amount? Go ahead and pause the video. All right, we're back. So Joe has $14 and saves $10 a week. So his equation would be y equals 10x plus 14. Josh has 26 and saves $7 a week. So it'd be 7x plus 26. Okay, so again, we're going to try to graph this as accurately as possible, but, leave room for error. So here, y equals 10x plus 14. So your y-intercept's right here at 14. And then you're going to go up 10 over 1. So if you're at 14, up 10 would be 24. Over 1 would be right about here. Up 10 more would be at 34. And over 1 would be right here. All right, and then we put a line on there. Okay, and then 7x plus 26. Let me get a different color here. So we'll start at 7, 5, 6, 7. All right, and then he actually has $26 to start with. So then you start at 26 and go up 7 over 1. So if you went up 7, that would be about 33, and over 1 would be right about here. Then if you went up 7 again, that would be at 40, which is right here, so over 1. And then you have a couple points, so you could get the line. And you see where they intersect right here. And that's at about 4 weeks. So at about 4 weeks, they'll have the same amount of money. And if you plug in 4 for both of these, you'd have 40 plus 14, which would be 54. And you plug in 4 here, you would get 28 plus 26, which is, again, 54. So they'll have the same amount after 4 weeks, and that same amount will be $54. All right, guys, that's it for this section. Please continue on to your assignment and let me know if you have any questions. See you then.